Are you planning on discussing system design with every chapter, or after this is something, are we going to like after we finish reading the book?
Yeah, so this is the basic agenda, right? And I was thinking that like if we have a calendar and we're following this, ignore mine. But essentially like I'll go ahead and try to like make it easier to read. Okay, so if we have, the group on this day, on Mondays, right? And then Fridays, we can say we'll do half the agenda on one day, right? And then half the agenda on the other day. So that's what I'm thinking. Like if we get through these 4 points today, then we'll do the other, 3 or 4 points on Friday. And then that'll complete the chapter. Because I think the last time I did it with Sadhana, I remember that this took a lot of time. It's a big chapter.
Yeah, I think it depends on the chapter that we are doing, right? So we can, if we say the first chapter has some Twitter examples, right? So we can just go over that. That could be a API design kind of a question that we can just discuss about. So yeah, I mean, that's probably the system design question is not mandatory, but I think going forward, the first chapter was it was just skimming the topic, so it was easy. So I think if you keep digging, you will find more involved technically deep questions. So I think that will take up time. So depending upon how much spare time we have already spent, we can decide whether we want to do the system design question.
Yeah, for sure.
Yeah, but I think we can alternate like chapter 1 and then one chapter and then system design question. One of us can come up with it and then we can alternate. I think that will add value. Yeah.
Mm-hmm. And I don't know. I mean, I'm open to maybe doing like a little bit more time if you want, to solve these problems. I don't know like everybody's schedule. So again, this is why I want to throw it out. Even though like we've created this basic schedule for today, right? Mondays and Fridays for 1 hour. I'm open to, adjusting it, because I know everybody has conflicts. And then I'm also open to maybe doing like, more time if everybody wants to do that.
Fridays, so I think half an hour more, I can.
Yeah, I can do Fridays half an hour more.
Okay. And is this time all right? 7:30? Or do you want me to start at 7?
No preponing, please. I am thinking of I wanted to check with y'all if postponing is possible. No preponing, please. It's very, very difficult for me.
Yeah.
Okay.
Yeah, so but anything later, Sadhana, it's already 8:30, like people have to head out to offices and all, right? So
yeah, I mean, as long as we're going ahead and recording it, I think it should be okay in case
yeah
we're not able to make it kind.
Okay. All right. Anything else about schedule? Is anybody? I see we have Karthik and RJ just joined. Do you all, Karthik and RJ, I know you might be, still like getting up or whatever, but if you have the book or if you read, anything, let me know. The schedule.
Yeah, I'm gonna be in and out. I'm gonna be mostly listening, refreshing it. I've read this book like maybe 4 or 5 times before, 3 years before. So, so I'm gonna just skimming
talking, not listening.
Yeah.
Sorry, what?
You should be leading the group.
Then you should be
3 to
talking.
4 times is like Karthik. I think even if we wake you up from sleep, I believe you will be able to talk about each of these chapters.
Well, to be honest, that should be the idea. I'll be very honest, right? This book is I would say it's a Bible for us, right? If you really want to build distributed systems, this is a definite Bible, like foundational Bible, right? Of course, there are a lot of things we need to cover, but ideally, if someone wakes you up from sleep, you should remember it. Like, just it should come. So don't make a fake pass. That's why I like this idea of one chapter per week, so there's not tremendous pressure, so you can skim through it. Most of the times, even today, most of the times people don't know what is the difference between real thing, the first chapter, right? Fault tolerance and like high availability. They think it's the same. It's not, right? So some of the things, it helps immensely to get perspective, to be honest, on this book. And I have a list of books as well, right? Like I told Vijay as well. This book, and there are a few other books that together I can suggest and you guys can go over as well.
Yeah, perfect. Also, I would like your take real quick, and then we'll go on to the book. I think I'd like your take on just basically like what kind of exercises you think we should be doing.
To be honest, I'm not a great guy on this to explain, but I like the idea of like being able to write some cheat codes, which is good. Actually, that's how I work. I like to write it. The reason I write it is I don't reference it, but at least when you write it, it just ingrains in your head, few of the things, which is good. I think, yeah, going over the chapter and looking into it first, going the whole book and then discussing the system design. I don't think there is much system design in this book. It's a foundational book which drills the concept better in the head, so we can tackle the system design concepts later. I have close to maybe 100 to 200 system design questions itself, like which I can bring it and we can discuss as well. Like, from ranging from foundational junior engineer all the way up to, in Amazon terms, L6 or L7. So we can discuss all those problems one by one. And it's available on the internet as well. So it's not, I just amalgamated it together.
Okay, perfect. All right, great. I guess last thing here before we move on is, does anybody, like I know we met each other at the last class. Does anybody here want to like say hello or reintroduce themselves or tell each other what we do? We can always do that also afterwards offline, but I'm just curious, like, it's always nice to know who you're talking to, and like what you all do. Maybe we should take like a second here just to like say what you all do, just for fun.
You want me to go? You first start with you, right?
Sure. Yeah, sure. I'll go. So basically I'm Vijay Menon. I work at Beachbody, and like I'm also like a meetup organizer for this group called Hackbuddy. It's like one of the largest software engineering groups out in Southern California. So I'm mostly self-taught and just trying to get better at like things like data structures, algorithms, and system design, and prepare for like some of these tough questions as they come up, because I feel like it's fun. It's fun to learn this stuff. Let's go on.
Yeah, I'm Amulya. I work at Amazon Chime. It's a service that that's part of AWS huge list of services. So specifically in Amazon Chime, I've been working on the authentication and identity management pieces. So earlier I had worked at Yahoo and in the real-time ad display teams, and then in EMC in the storage, basically C++ coding. But right now I'm exclusively working on Java, also a little bit of Ruby and Ruby on Rails. Any Ruby programmers here?
I know it. One of my friends really loves Ruby on Rails, so he's always talking to me about it.
Yeah, I mean, it's kind of Java is so readable, right? Ruby is like does a lot of magic in the back end. So I mean, like in the background, so you have to really understand the semantics to kind of kind of take it up. So anyway, yeah, I'm also self-taught. I'm not a computer science graduate. So yeah, so there's a lot more learning to do. So here I am.
Awesome, great introduction. Let's go on to.
Let me go next because a lot of things, whatever Amulya said, right, would match with me.
Mhm.
So I work for Microsoft, and I previously I used to work for NetApp, so that was also a storage company, and mostly into storage thing. And most of my experience in at NetApp, at least, has been in authentication and identity management, all of those things. So there's a lot of similarity, looks like. Yeah, previously before joining this team, it was mostly into C++. So now here I work for a CASB solution. So this is a security product which kind of protects all apps, all applications.
Very nice. It's good to know everybody's strengths. Actually, this is really good to, just knowing like what everybody does can help. Let's go on to Akanksha or
Yeah, can go next. So I'm currently working with Dropbox, and I'm in the product platform team where we are responsible for scaling different services, building out tools for different teams, which can with the help of which we can detect different deadlocks, query performances, and introducing improvement in Redis. We are right now I'm working on moving from MySQL to Aurora. That's one thing. So whatever solutions we are using, how to leverage them, how to scale them so that different teams can roll out their products very easily and build up code very easily. Prior to that, I was with GoFundMe, and I was working on the payment side. So I have a strong payments background, and jumping the ship to Dropbox has been moving totally out of my comfort zone. So I'm playing around with something totally new, which I've never done. Yeah, that's about me.
It's awesome. And that's great that you took that challenge. Let's go on to RJ.
Yeah. Hey, my name is Mithun Raj. I go by RJ, and mostly work as a backend engineer at Twitch. So the product I work on is mostly like video playback. So, and also like I work mostly in startups, and this is the one like in Twitch is the one where I have to deal with a huge amount of scale. And also Twitch is also part of Amazon, and they have IVS product, which is for interactive video services. So yeah, it's been good so far.
That's awesome. And
Actually,
go ahead.
yeah, so I was wondering, so RJ, you're so there's a guy in Amazon Chime org who moved to Twitch. I think he's the head of the Twitch. I think he started when the acquisition happened, he started leading the group. Christopher Lafata, Topher.
Christopher, yeah. He is in
Yeah.
the same org.
Yeah. Anyway, so yeah, he was my colleague. I mean, not he was senior to me, but yeah, we were in the same team.
Oh yeah, they call him Topher.
Yeah.
Okay. Yeah. Cool.
Awesome. Let's go to Karthik.
So yeah, I pretty much come like you guys, self-taught. I had an electrical engineering background, C++ I had in the curriculum. It sucked. I never wanted to work in IT industry. But here I am, like I have about like 18 years of experience, mostly IT consulting in middleware integration, API space. And then now I'm in Amazon on the customer facing org, where I go to different customers, help them use the cloud or have them adopt to cloud, but mainly move from microservice journey from monolithic, and then weave in all the bells and whistles, observability and everything, all the good things that the world talks about in Kubernetes and stuff like that. But yeah, I never been an SD. I mean, maybe early in the career, I was a product engineer and building out a BPM suite. But yeah, I would say master of none. But I cover the breadth in the sense, yeah, Java is the primary bread and butter. But like I also code a little bit in Scala, Golang, depending on the job, right, and Python. So every consulting gig I go, it's a little different. And also I'm a huge fan of automation. So DevOps, any process improvements, tools, building tools, CLI, everything. I dabble around a lot, but I'm not close to anywhere as good as you guys in the algorithm or whatever. I'm pretty bad, but yeah, this is system design, so I can survive, I guess.
Yeah, actually, one thing I would like to add, I also did 2 years of something like a security consultant role at NetApp. So I pretty much, I'm also self-taught. I'm an electronics engineer, electronics, and I also like to kind of experiment, learn, try out new stuff to see where exactly I think I like the most kind. So.
Yeah, I mean, I love this because I get bored doing the same thing over and over. I don't know. My mind is wired like that. So every 6 months, I just change the customer because you learn everything and it becomes boring after a while because it becomes easy. So yeah.
All right. No, this is good. And actually, for the record, is anybody here really good at data structures and algorithms? Because I'd like to study with you on that as well.
Let's do this properly.
Okay. All right. So
I mean, these are deep, right? Like once we discuss, I think we should also spend the time to ponder and kind of really digest the material. So we don't have the need to reference. Ideally, you should just, you should actually incorporate, and this should become the way of thinking. That takes some time to kind of sink in, the concepts to sink in. So I don't think we should try to do too many things at the same time.
yeah, no, I was just down the line, like saying.
Yeah, sure. Yeah.
Okay, so
I'll be the last person to drop off. So I mean, like to not attend this enthusiastically. So yeah.
Okay. You got it.
Me too. So you'll have some of the other company, don't worry.
Okay, so I'm gonna just jump into 2 more things. Again, today, like I think the first thing I want to nearly get is the schedule and like the organization hammered out. So
yeah, and one more thing, Vijay, just before we started, perhaps I think you have not joined the WhatsApp group, or probably it'll be easy to converse in a WhatsApp group. It'll be great if you could also join in that group.
okay, yeah, sure.
Yeah, I'm planning to do as well. I couldn't figure out how to do. See, I'm a little bad in this. Like, I was like looking at my laptop and I was trying to figure out without having to add the web. But I'll join today. I think I've added it.
Yeah, that kind of gives easy communication. I somehow like.
Give us your number. You don't have to do anything.
You got it. I was actually about to say the same thing. I don't know if you all added Discord. This is a app that I kind of use to just kind of talk to everybody. But you all can definitely, we can also do the WhatsApp if you want. I think that this might make it more accessible for anybody who joins later or watches online. They don't have to use their phone. They can use their computer as well. It's very similar to Slack. The nice thing is it has integration for a lot of different things like Zoom and Google Meets built in. And so I like you have a voice call, you have a video call, you can pin messages, you can search messages. And so it's really easy. Like I think I just put the link in this chat here.
Can you record?
I think you can record. I'm not sure. I remember doing a video call before and then recording it inside one of these chats. But again, not sure. I think you can.
Yeah.
Is that basic question?
You can record, then we can ditch Zoom and be there. One tool, right? Like instead of having.
So I think Zoom is a better experience. I don't think Discord is better at like doing video, but it's nice for like quick calls. Especially if you're like, hey, I really liked, what you were saying or what was said in that, meeting. Do you think we could do like a one-on-one? Then it would be great, So So the simplest way is just like to join the Discord, and then my name is just Vijay right here, right? So we have lots of people online. If you ever want to like ask a question too, you can definitely ask the question. But just add me and then as your friend. And then basically you can start chatting, and we can always have a group discussion in here as well. Again, the reason I only bring it up is because, I understand people like WhatsApp, but like I have to use my phone. I actually like just being able to type on a computer or any device.
Yeah, we can use that as a as our like computer, basically for elaborate chat discussions. We can probably use that.
Yeah. I would do Slack too, but I think like the problem with Slack is that like I always have to pay more money like just to do more integration stuff, whereas Discord seems to be free. So it's good. Okay, so I also shared this working document here in the Zoom chat. So you have 2 links. So if you if you ever like, what did we go over? Reference this doc. It's probably going to be raw, meaning that like, we're just going to put a lot of like outline notes, and it's going to be unorganized. But I think like we can always have somebody volunteer to organize the notes each week. And it'll be good. It'll be a good way for you to like remember what we went through. And we can alternate that.
How is Notion for this? I think Notion is probably shared, right? I mean, you have to pay, I guess, if you want to do it as a team.
So I really love Notion. I use that myself for a lot of different things. Again, though, I'm starting off with like the basic thing that most people probably know, which is Google Docs. But if everybody feels comfortable, we can definitely move it towards,
No, there is a template for notes taking in Notion, which is why so there's a template called Cornell note taking template. So it has a really nice format. Yeah. So I started using it today morning when I was reading the first chapter. So basically there is, you have 2 columns. In the right column, you kind of, you write basically telegraphic notes, like while the class is happening, you kind of make notes, and then you have keywords on the left hand side. So when you, so let's say you want to quickly revise what went through. So you basically you just look at the keywords and see if everything is ringing bell and you're able to put things in context. And then you summarize at the bottom what is the key takeaway from the chapter.
Perfect. I remember this from like reading like a book. This is one of the best ways to take notes. I'm okay with doing something like this if everybody else feels comfortable. Again, like I'm just going with lowest common denominator because I think more people understand docs than Notion. But what do you all want to do?
How are we going to get access? So can you share that? I think, I don't know if I've not a user of Notion yet, but
yeah, I would need to research this for you all, or if you already know ahead, Amelia, we can find out. But I have no problem taking this and then moving it to something more sophisticated later.
Yeah. Why don't I keep the notes for you for this class and see how if it's because I already made some notes. I can add to any new things that we discussed to it, and then we can review next class if that thing works.
Sounds good. Okay. And just really quickly here, checking to see if they have Cornell note styles in Google Docs. If not, we can use like the same template where we just kind of, like the way I do my notes is essentially I kind of start with headlines like this, right? And then that would make, like the thing that I'm going to be talking about, the section. Then like I have, just like a smaller headline, right? Which is unbolded. So this be like a heading. And then, like some information, right? Like, so I used to use bullets, but then like I stopped doing that. I just kind of do, like a note, and then like I use two spaces, like in computer programming to like add some information here, like if it relates to this. So although you can just use the tab thing, so that's kind of like how I do it. I just kind of say note and then subnote, and then when I'm done, I just kind of go back, note, subnote, and then later I'll just do like a summary, like TLDR, and then that'll be it, right? So that kind of matches up with this keyword, notes, and then summary.
Yeah, so I just looked at the, so apparently I can publish the notes to, so in Notion, you can publish and like anyone can see, like I can publish to the web or I can publish to a few people. So I guess it's, you don't need to be a user of Notion to access it, is what it is.
Okay, let's do this. Let's go ahead with this format for today, and then we'll do another call at some point on using Notion. That way, if it gets overly technical or hard, we can sort all that out.
Okay.
Okay, so let's go ahead and jump into this chapter if everybody's ready. Okay, so so this one, is a really interesting chapter in my opinion. I think the way to go about this is like I'm just going to kind of go through each page, and then we'll kind of talk about like these different things. If I can either ask somebody like what's your take, right? Like what's your experience on it, or what do you understand from this particular section? And then they can kind of say their thing, or we can all just kind of like do it voluntarily. Somebody can just kind of like jump in and say whatever. I'm open to both formats. But so with that in mind, basically, this whole chapter is about like this theme: reliability, scalability, maintainability. So I just want to open up by asking, what do these things mean to you? If anyone wants to go first, that would be great. Otherwise, I can just ask somebody at random.
I can go.
Okay.
If nobody's talking, I can default to talking.
Right. Yeah, just jump in.
So, what is reliability? So, of course, I mean, every org and every company has their own definition of, so there's this introduction of this technical jargon called SLA, right? SLAs and SLOs. So AWS has a defined SLA for all the services under its org, right? So it's 99.99% for on availability. Actually 99, I think we call it 5 nines. So so basically so downtime is not accessible, is not acceptable. Doesn't matter if you're upgrading, you're doing some it's unexpected bug, whatever it is. So basically you should always do safe deployments. The service should be always available, and we have defined latency SLAs, stuff like that. So so how I define reliability is I read the book, so I'm tempted to say what it is saying. So, but yeah, the book says that reliability is effectively how your service performs when the dependent components don't, like, they're given, right? So anything to add here?
Yeah, feel free. Like, and when you, for now, like, unless like we really want like a huge technical answer, feel free to just kind of give like 1 to 2 sentences what this means to you, like for everybody, like not just one person, like 1 or 2 sentences. We don't want to get super heavy until we really need to.
You're asking me or like asking somebody?
Everyone. So I guess I can ask Karthik, what does this mean to you?
Reliability means any particular service or any particular function to be working amidst of failures scenarios or functioning exactly how it's supposed to, irrespective of The things that Amulya mentioned is right. Deployment, that is availability perspective. During deployment, it cannot go down. Rolling deployment needs to be done. You need to SLA, SLOs are defined, and there is SLM which measures it against it, service level monitoring. So these things come into play to check if the service is up and running. So that's more in the availability category. That's one of the, I would say, pillar of whole reliability, but also the function with the data, right? Let's say you pass in data and it's getting stored, persisted. Is it getting persisted in the right way? Is it not dropping any transaction? Everything comes under reliability, right? So basically, a particular task X does something, like let's say it does Y and Z. The whole transaction or whole perspective of having it to work to do that, and if it does correctly, that's reliability.
Awesome. Okay. So yes, yeah, I think everybody's kind of like saying, similar things too. So for me, I kind of, what I was thinking like these three things meant was, I kind of felt like with reliability, it's more or less, you're trying to like remove the idea of like error, like human error, especially, or software error. You're just trying to say like that whatever your device is or your application is going to be on, and you can count on it being reliable. It's not going to break, and it's thoroughly tested. Scalability to me is like, I think that's like the theme of like, our age, right? Like if you were to like say, what is 2022, or like, all the way up to like, this past decade, it's about scalability. And, I was actually kind of thinking about it, even with this past weekend, I was having a family discussion, and we're just kind of like talking about like YouTube channels and, Udemy and all this other stuff. And, it's so cool that people can just make like some kind of thing, right? Like you can make like a video course, or you can like make a product, and you'll reach like millions of people in this like era, right? That was like unheard of in any other time frame. But now literally you can like do anything. You can like make cat videos, and you can reach millions or billions of people. So scalability is like a huge thing, and it rewards you so well. So just being able to be a company that scales correctly is a huge plus in this modern era. And I think this to me has like the most weight out of these three different like categories here. And then maintainability for me, the last part, I think it's common sense, but like I think we kind of forget it. Like, keeping the system, right, that we built simple to continue to operate and improve on is like key. Because like I think as programmers, right, like we tend to love complicated things. We tend to love complicated programming, because then we can pretend like no one else can read this, right? I did it, it's mine, don't touch this project. But I think like the key to like a really great application all in and around, right, and a great business all around is just being able to evolve it and maintain it. So I also really like this keyword a lot. It's one of my favorite ones. I love to keep things simple. Anybody else?
So because there are this multiple, there are folks from Dropbox and other companies, right? So how is there any emphasis? How is the emphasis distributed in Amazon? At least availability and SLAs are kind of it's heavily emphasized. Security, all those security and availability is like top priorities. How does is it a company culture? How is it in your orgs? What are the emphasis?
Again, it depends on the size of the org. Like I worked in startups. There it is more like there is not that amount of scale or the RPS, request per seconds, right? So it is mostly like, is it reliable and is it working? The scale comes into picture like after the fact. Like I worked in like companies which is like still raising like 6 million kind of funds, and there it was mostly like trying to basically production, like testing out the product, and if the features are liked, then trying to do that. Then working in other size companies, it is again different, like like Twitch. Again, it is availability, like to reduce the blast radius. Are we multi-region? If because all the things always goes down. That is how I think most of the things is trying to like include that as part of any design. There will be things going down. If there is things going down, what is the like alternative for some data source, or is there any default behavior we can rely on, or like those kind of stuff, I think, when it is at scale. But again, those designing system, I think it is, if it goes organically and evolving, like it depends on what are the constraints in startups or in smaller things. Like when you introduce like scale and everything, maybe that is not needed at that point of time, because
Yeah.
you don't need the complex system.
Yeah.
So again, it is a trade-off, like at where you are trying to design, I guess.
Okay, I would say it is more to do with the kind of products. Now, most of us are kind of building products on cloud, so availability, security, all of those things, a lot of emphasis there is there. But back few years ago, right, I have worked on products which were deployed on-prem. So reliability was also a very, very, very major thing. So a crash was always a seven issue for us. Nothing to compromise. Any kind of a bug which causes a crash is always a seven. This no matter what. So nowadays, if there is a crash or if there is a software bug, we immediately raise some metrics, and then we kind of do some work to immediately see how we can fix it. But I think it totally depends on the product, which product and the how exactly it is being deployed and how the consumers are consuming it. So if it is a service which is hosted by us, definitely availability and security comes primarily the beginning, the first priority kind.
Right. So this is good. These are good discussions, actually, because this is largely what this chapter is also about. Just I heard things like checking for software errors and making sure that we properly test. That goes back to making sure that your system is reliable. Real quick, let me just kind of ask here. As we scan some of these pages here, right? Like I made some highlights already. And I highlighted kind of things that that seemed to pop out at me as I read this book. Obviously like CPU power and what does the word data intensive itself mean, right? Like that's the name of this book, Designing Data Intensive. So just like, I'll say like the thing that kind of stood out to me about this is that in this chapter, right, data intensive was used a lot. I think it was used a lot here. You have to probably look at how many times like this was referenced in this chapter. But data intensive, like is interesting because in the past, like we would say things like CPU intensive, right? Like that's what I've highlighted here, where an application takes a lot of CPU power. However, a data intensive application is typically more, something that consumes, lots and lots of data, right? Like, like instead of like jamming up a computer's CPU, you're jamming up a computer's hardware and, memory, right? Like as you fill up one block, you'll need another and another and another. And that's what causes the scaling problem for a lot of companies. And so you need a way to kind of manage that, right? So that is the data intensive meaning, in my opinion. Does anybody want to add to that?
At least for Chime, it's not an option to be, compute intensive. I think the kind of applications that we work on, they have to run on mobile phones, which have very limited hardware
Correct.
capabilities, right? So if they are compute intensive, they're like basically they make the mobile unusable. So I think the nature of our application, basically the frameworks that we use have all been designed to take the compute problem out, and like we have the data, basically the way we persist data, it's all, so we basically are ready to be consumed, we kind of simplify the data so that it's ready to be consumed and we don't have to process it on the fly when we have to use it in some format. So I think compute intensive, we have advanced frameworks and libraries that kind of simplify the problem for us. So it's basically the dealing with the data that is specific to the application and its scale that we are basically solving here.
Right. There's a lot of things that you have to do with data,
With
like
Twitch
go ahead.
is like both. Like there are compute intensive
Yeah.
because video processing.
Yeah.
Then also now trying to move the video streams, that is data across. It goes on the network. So yeah, it is both. It depends, I guess.
Yeah, good point. Yeah, video streaming apps need to have a balance, like how they perform on apps. They have to optimize for compute as well.
Right. Okay. So, like, again, I've highlighted some words here: databases, caches, search indexes, stream processing, batch processing. These are all jobs that are data intensive. So basically, I think, most engineers have to think now about not just the CPU, but also the data, right? Like if you're going to design a large application, how are you going to make sure that your application can handle, these data loads, whether you use strategies like databases or a cache or a search index. And these are things that we can probably, system design to, like, as we get to a later date, like Friday or next week, start thinking out these processes. I think it would be good to maybe like draw it out on paper, or maybe if you like using tools like Sketch or Draw.io, those would be pretty good. I'll just demo Draw.io real quick. It's a place where you can go and you can basically create like diagrams. So as long as you authorize your account, which I had to do, you should be able to get in here and then basically, start working through like little diagrams here. Looks like it didn't take mine, but I think, so let's decide on what we like. I think that we can do Draw.io or Figma or any of those things. Here we go. It's just me like not knowing those.
Draw.io. There's a desktop application also, so it's pretty good. So
Yeah.
So here you can see these things have flow charts, entity relations. It's easy to like make UML diagrams. So could be good. You can also just kind of use like basic boxes here, like to just draw something and connect something to each other. Like this diagram here usually is like for an if statement, right? So you like say this. So if true, then do this, else, do this other operation, something like that. So we can always go over like an exercise on how to use this or any tool we like. For me, I feel like this is really straightforward. I just can create boxes and then drag arrows. So I think it's simple enough to use. So I think like maybe as an exercise for everyone here, maybe just, like pick one of these, bullets here, and I'll go ahead and put that into, our notes for today, that we want to like kind of, just kind of understand what these things mean, like databases, caches, search indexes, streams, batch processing. So if anyone wants to kind of like pick one of these and just draw out like a quick diagram, that would be great. Just like, what is
So I think like it's good that you're defining, but calling it out specifically, what data intensive applications, right? Is it write heavy? Is it read heavy? Doing that classification will help us apply these kinds of, whether cache is never used in write heavy things, it's mostly a read heavy component, right? Because mostly used scenarios is when those gets cached and there is TTL, time to live mechanisms available for content like video and graphics. It's cached not at the API layer, but rather at the cloud layer, like our region specific at edge layer. It's called CDN. So there are different, all these tools don't fit for just, if you're gonna say just data intensive applications, it might be a little confusing. Having it segregated for read heavy, write heavy kind of a logic will give us a better perspective. That's my thought. Like again, if we don't have to dwell too much into it, I'm okay with it.
Sure. I'm just like putting over here just kind of like a note. So like if you don't have to again go super deep with a lot of this stuff. I think it's just great to just have an idea of how these things work. Just if you want to like give like a summary too, like a quick summary or like a quick visual, that would be great. And I'll put instructions on that later. I think it's just good to just know these things, like what these things are as we kind of get more complicated through the book. But yeah, like the next part here is kind of like, it was kind of like saying, thinking about data systems, right? Like what is a data system? Again, like thinking about a data system. We have databases, queues, and caches, and these are different categories of tools. You have message queues, and let me go ahead and move this Zoom thing out of the way. You have tools like Apache Kafka and Memcached. Has anybody here used Kafka or Memcached?
I've used both.
Okay, why don't you share your experiences? What is that? Like, what is a Redis or Apache or Memcached, like, at a high level?
So Redis is just a caching layer. I mean, it's just for, I would say we are using it for read intensive, improving the read intensive application performance side on things at Dropbox. And Kafka I had used in my previous job, where when the stream of data is coming and you want to process it in a certain way, and you cannot say you want to handle the volume of the payments transactions that are coming in asynchronously, or there may be tweaks involved where one thing should depend upon another, like one transaction is depending upon another. How do you want to go about it? So Kafka is good for handling both the cases. So, and we were using it for both the cases, especially on the payments webhook side. So it played really well, and it also, it handles the greater volume to a great extent. Yeah, and the good part is that you can publish message from one microservice to, you can publish the message and then another service can consume it. So it can be easily be used, org wise. So yeah, it can easily be expanded, I would say, in the org.
Does it guarantee event order, like the?
Yeah,
You can
it
do
does.
that. Yes, it does. Yes, it is all configurable in Kafka. Yes.
So I have the great examples, Akansha, but like a very layman's term, if I were to any messaging system, forget Kafka, right? Kafka is like the newest, like distributed messaging system, but messaging system has been there for a long time, right? Be it from Tuxedo days or IBM MQ, even Apache ActiveMQ, RabbitMQ, and Kafka, just to name a few, which are generally highlighted. So any processing that needs to happen asynchronously, right? Long-running jobs. Our typical synchronous job or synchronous API calls, if I were to say, is the maximum defined time is 5 minutes, after which it will time out, right? Any long processes that you're going to define. Of course, none of the clients are going to wait for 5 minutes, right? You need to wait for 5 minutes and consciously do that change for you to wait. So nobody's going to wait for 5 minutes or whatever, right? That's the defined spec.
Right.
Anything that you want to process behind the scene fast enough. Sorry, oh, you're saying something?
No, go ahead.
Yeah. So nobody's going to twiddle their thumb and sit on the front end UI today. The pace that we work. So any job that cannot be done, let's assume like under a minute, 1,000 milliseconds, right? That's a stretch too, right? 1,000 is a lot, but anything that you want to process behind the scene is asynchronous communication, and you want to be introducing some kind of a messaging system of sort, which is going to go and do whatever it has to do behind the scene and get the thing done. For example, one of the things could be you just like, ask for add a new user for authorization, and then those things happen fast. But if you're going to add a new user from different groups and stuff, like sometimes you get a message, okay, you've been requested to get added. So behind the scene, it will get processed, it will get added in its own sweet time. And then you just send an acknowledgement. It's referred to get as well, models.
Yeah, I think later in the chapter they talk about the Twitter example, where they say if a popular celebrity kind of publishes like a tweet, it is followed by like some 30 million people. So stuff like that can be an asynchronous job to kind of push these tweets to all the followers. So yeah, messaging tools like Kafka. AWS has a SQS, has a service called SQS. So I think it's available.
Somebody tell me the difference between SQS and Kafka. Like, where do they stand out, and when do we use one versus the another?
That's why I was asking. So SQS also guarantees message delivery in the order. Yeah, that I don't know. I have not used Kafka. So I just know that Kafka is not Amazon offering, so that's why we don't use. But yeah, I mean, SQS also.
Actually, it is, Amulya. I'll send you the page link. Amazon managed Kafka as a product.
Oh, really?
The reason why I know all these things is, sorry?
I always thought Kafka was from Apache Kafka, right?
Yeah, it is Apache, but actually it was built in LinkedIn. And then it was donated to Apache. Now, like we have Apache managed Kafka and AWS offering too. The reason why I have to look into these things is every client that I walk into is a different environment. So I use Kafka now, specifically in a gaming industry where the latency of APIs is under 10 milliseconds. So I know it's offering from AWS.
Oh, so you're saying that it has a better latency in message delivery to the subscribers?
Oh, no. What I'm saying is their requirement is under 10 milliseconds, right? So we are, I would say we are like breaking down some of the APIs and trying to build better messaging system. So, okay, going back to the previous question, why would you use SQS versus Kafka? If I were a customer, think of a scenario of some kind of a software where people are hosting it in the cloud, but also there are some customers where they would go deploy on-prem. They're on-prem, or it could even be on Azure, or it could even be on some, think of like somewhere in China in Alibaba Cloud, right? Or completely a new data center. Kafka is open source. You can go and like install that on their on-prems, right? Predominantly. But SQS is a proprietary tool. You can only host it in AWS. You cannot take it and deploy it on-prem. That's the number one criteria. Second is operational cost, right?
So what do you mean you can install on-prem? Like you have to bring up servers that do this Kafka. People do that, like they bring up their own. It's not offered as a service, but anybody can install it and bring up their own servers which run the service.
Absolutely, yeah. Why not?
Oh, is that how it works?
We that for, we tried it for a hackathon project. We used RabbitMQ, where we just downloaded all the binaries and then ran it in our product. We just integrated it and ran it.
Yeah,
so it's not
so,
used as a service. Yeah,
I will actually maybe not now. I'll actually at some point create something and give you guys where you will be empowered to do all these things on your local laptop without having to, basically use Docker and stuff. Think of it this way: the real world, I've seen the world before the real cloud,
right? Like where data centers and you go install, do all those things. But surprisingly enough, not everybody is in the cloud. I'll tell you, only 3% of the world's population is in the cloud. That's why I have a job, right? Helping them adopt into the cloud and stuff like that. But there are customers who still want to go and deploy on-prem their own.
Okay, so that's the difference there. So basically, SQS is offered as in some remote service, whereas Kafka could be your own in-home thing that you are running. Just deploy and get it running. But
where the whole network is protected. It's mainly think of banking industry. They're very stringent with security, data, everything. So banking, BFSI sector itself.
Got it. I never knew.
That was a great example, Karthik.
Yeah, thank you. It was excellent. So maybe we should have you.
Forgive me, I'm just trying to drop my kids. So sometimes they're just crying, so ignore it. Sorry.
No worries. And I was actually going to say we are 6 minutes over, so I wanted to just kind of ask here: we want to keep going, or do we want to just kind of like put a pause here for today and then pick up Friday?
I think we were not focused today. Like if at this rate, we are going to be stuck with the first chapter.
Well, it's to be expected. Today is again like the first day to just really, like meet everybody, talk about schedules, which is something we accomplished, how we're going to do note taking. I think we accomplished that. And then just basically like the tools we want to use, right? So it was actually a productive day. And I think we even dove into like beginnings of this chapter. So that's good. So I think we can also hit the ground running on Friday and like do more deep dive into a lot of this stuff.
Actually, now I see
maybe Friday I should talk more on Fridays. I'm just derailing you guys in my opinion.
Yeah. 1 to 2 sentences.
Yeah, so we should also kind of read upfront and kind of post the questions specifically that we want to cover ahead of the meeting, so we don't get derailed. Right. So we kind of get what we are looking from the community that we are, right? So everybody gets benefited. So yeah, we can use that whatever the Docker tool that you said, and kind of post our agenda that from my perspective, what I want to discuss. If you post the questions there, then we can kind of try to accommodate everybody's questions.
I think the Docker was more to do with experimenting all these services which can be done, which can be actually tried out on our laptops. And here we will use our, what do you say?
Discord, yeah. There's a Discord versus Docker, yeah.
Oh, right. I was thinking about, so yeah, you also have Discord, so you can use Discord. You can reach out to me, and we can also use WhatsApp if we want. But I think again, if you're interested in being able to do stuff on your computer, I think Discord is a little bit better. So just let me know.
Just before we conclude, right, I just wanted to bring up one question. I had this question when I read this chapter. So I think the author had mentioned telling people use Redis as a message queue and Apache Kafka as a database. So I haven't really seen such things. Is it being really used in the industry, and is it like how good is it to use it in that sense?
So the thing is, I have seen one of the startups, they used Redis as the database and the problems associated with it. I led that team, and I was the first one who took it down right away. Right, the amount of
database you're telling is a problem. That's the standard way of deploying, right? I mean,
no, never. Redis not as a database ever. If for prototype, it's okay. Right, not Redis is not a database, right?
Redis can be used as a persistent memory.
It can be, but real world you don't want to. You know what I mean?
It's mostly used as an L2 cache layer kind, right?
Caching is fine, yeah. But they use it like a database itself.
Caching plus persistent. So it's like L1 caching in memory cache, L2 caching where you are using a persistent cache, we use Redis.
So persistent cache. So yeah, it can be used as a persistent cache too, Karthik. We actually use it as a persistent, not as a cache, and also a persistent database as well. The reason we use is that it kind of I think DynamoDB also offers it right now. You can kind of configure the entries to be expiring, self-expiring. So we have we have a use case where we want a certain entry to be there and be expired like 2 hours later. So, and it's a high volume use case. Like basically, we'll be creating a lot of entries. So that is where Redis works really well.
Right. What I meant is like they didn't have a database at all.
Right now it is that we use that. That's what I'm saying.
Yeah, but your data is short-lived. Their whole data and transactions were long-lived.
Right. Yeah. For that,
different use case.
Use cases.
Yeah, but preferably not, because Redis doesn't do replication very well from a fault tolerance perspective. If the data is like highly sensitive, you don't want to just store in Redis. You need 2 layers, right?
Yeah,
one good persistent somewhere, right? MySQL or Postgres, and keep it in Redis for in-memory cache, which is great, right? And TTL, if like you mentioned, the TTL is 2 hours, it's okay, right? Which means it's not something consequential, even if you do lose that, in my opinion.
Okay.
Hey, I'd like to point out one thing for Redis. Like our current team is facing these issues. Like I faced this last week. So with Redis, the amount, say you, with a TTL, you're introducing something, or the amount of traffic hitting that particular, whatever you are storing, say I stored something for 2 hours, right, in Redis, but the amount of traffic hitting, so there was something stored for us for like, say, 3 hours, and the amount of traffic hitting for that particular specific experiment, if we introduced a new experiment and we introduced the split over there, the bandwidth of the Redis server and the CPU consumption had, like, it was, we couldn't handle that, and we had a SEV because of that. So I just wanted to point out, when you are storing something in Redis, be aware that the amount of traffic hitting for, and trying to read that particular key is also important.
I didn't get that. So you said if you're
say you're storing key is equals to the value of key is X, and say 90% of the traffic hitting from your website is trying to read that key, right? So maybe there are a lot of hits happening on Redis, right? So imagine 90% of the traffic trying to read that key value from your Redis storage. So imagine if it cannot handle the bandwidth, your bandwidth is like, it is not able to handle that many of transactions that are trying to hit on the Redis server. So that will be bad for the performance of your Redis server. This is something we recently faced last week, and we had to increase our number of instances. We were also not on auto scaling on that side, so we are exploring that part for now, but that is something we recently faced.
Okay.
The memory requirement, Redis is more a memory than CPU in terms of things. So
yeah, but
you have to just give like a lot of memory to it.
No, but like,
go ahead.
No, so I was saying that if a key is being read quite quite a lot, shouldn't it be cached, and shouldn't it be, I mean, why should I mean, that's the point of Redis, right? It's supposed to.
Yeah, absolutely. If caching, yes, caching is, but when you deploy with caching, right, you always have a fallback layer. Let's say for whatever reason, if your caching fails, still your system should perform just fine. Right. So what is a backend mechanism? Then you have it in the persistent layer. Yeah, sure. Your transactions are gonna, latency is gonna increase, which is okay, but still the reliability part that we spoke about is intact. Someone is calling the API, they still got the result, maybe not in 20 milliseconds, they got it in 200 milliseconds. But think of Redis as the only database layer. If you use Redis is in a high availability mode across, any failures, it still be able to handle, great. But say, again, this was a startup. They didn't have the luxury of spending so much money. A lot of things comes into play. Cost effective, still high availability. So the scenarios were a little different, but yeah. I should give that context.
Got it.
Okay, good stuff. All right. So again, just asking for time. Do we want to extend the time or do we want to kind of stop for now?
I have to drop off actually.
Okay.
I have to drop off too.
Okay, so then we'll pick up Friday. Again, please check the notes here that I've put. Feel free to add your own notes if you got anything or there were discussions you want to like continue to look into. In fact, I'll put a little column here, discussions or questions from the group. That way, like, you know, if you have specific questions, like how does this technology compare to the other technology? You know, you can like ask a question here and then somebody else can fill in the blank or give a link to it. And I think that would be appropriate because I did see some links get shared. And, you know, we can continue discussion that way. And then, yeah, just like, let's continue reading this chapter and, you know, just organizing our thoughts and like planning in advance what we want to ask. But otherwise, good meeting today. I really enjoyed seeing everybody come and this is good that we got all of these questions hammered out at the beginning. One, you have your hand raised, Karthik? Or have you just been raising your hand the entire time?
That was, yeah, a long time back. Like I'll raise it down.
Okay, perfect. All right. I think we're good. Anything else before I stop?
Oh, good start, guys. Yeah, we should bring the energy and kind of. I will add my notes to the to this doc.
Okay, perfect. All right, and then you know, maybe we can plan for like migrating this to Notion at some point. We really want to. So just let me know. What I'll do actually here is on Discord, I'll create a group for us that we can just use, and I'll call it system design. And I guess, I don't know, just keep it public for now. But you can all just kind of say hello in here if you want. I think you should be able to like get basic access. This doesn't seem like it's a private channel. Oh, it looks like it is. Oh, well, I'll fix it. But I think you can just start working in here and you know, say like whatever you wanted to say about like further questions, and we can like go about this.
Yep. Yeah, and also ping Krishna if he's interested in joining stuff, right? Yeah.
Absolutely. He's I'm still talking to him. So like I'll make sure that I send him these notes and also the video that we did today. All right. Thanks a lot for coming. Have a great day, everyone. I'll see you all.
Thank you.
Okay.
Thank you. See you
Later,
all.
guys.
See you later. Bye.